Hello, class. Today I'm going to come to section 10.1, radical expression and functions. And let's start with some notation, right? So notation. Okay. So in this section, we have this notation called radical. So this is radical. And the one inside, let's say A, here is called radicand. So let me write as a red color. So it's radicand. Okay, so and let's use other colors with an N over here. And N here is called index. Okay. What does that mean for this notation? This means that I should say like I should say radical of A radical index n of A equal to B. It means that B to power n, maybe I can use other color, n equal to, let me see, red one, A. Okay. So just keep in mind that the radical for the root of n, or the index of n, of the radicand is A equal to B, is mean that B to power n equal to A. Okay. So let's talk about index n. So index n have two cases, or I'm gonna say like index n's. It has two cases. One is if I have an odd index. So then in this case we are finding an odd root. Okay, and in the case that n is an even, we are finding an even root. Okay. So let's have a special case. Case where n equal to 2. We will have the radical of A with the index is 2. But the mathematics just want to write it as square root 2 of a with no index. And whenever you see the radical with no index here, it's actually mean that it is square root 2. And the index in here is number 2 hidden. Okay? So just keep in mind that. Let's see. So let me have an example. So this is called like square root. Square root. Okay. So we know that 6 squared equals to 36, right? And negative 6 squared equal to 36 also. Okay. So what about if I want to rewrite it as in the radical form? Okay. I can rewrite this as square root of 36 equal to 6. Okay. So let me circle this one. What about the other case over here? If you want to rewrite this at the radical form, so you're gonna write as square root of 36 equal to negative 6. Okay. However, this is an argument in between many mathematics since about a square root of something will never given you a negative number. Okay, so and someone also believe that it can still have have include the negative 1 here because the negative 6 like negative of 6 square is still giving you 36, right? Okay, so even those, if some of you maybe take a look at the text for this class, and you can see that the text even accept this answer, but Mr. 2 gonna say this is actually not a valid, okay, not valid answer. Because why? Because we are talking about the functions, right? And since the function is mean what? 1 since it's a function. So then one input will give you, or will have exact one output. So you cannot have like one input giving you two output. So look over here. The input was square root of 36, but giving you 6 and negative 6. So this is not a function, right? How can we call this a radical function? So I still believe that you just gonna, I'm gonna just accept the answer as 36, square root of 36 equal to 6 only. Okay. So, and if you go to the next level, I'm pretty sure you have to remember this. Okay. Okay. So now let's make sure that the 1 square root 36 is not going to be equal to negative 6. Okay. So remember what I teach you. And let me have an example. Say example 1. So evaluate a square root of 25, b square root of 4, actually, 4 over 9, and then c square root of c squared. Okay. So let's start with example A. I can right away know that square root of 25 will be equal to 5. Because what? Because we have square root of 25 can become 5 squared. Right? You know that, and then you can cancel the square from the square root and get only 5. Okay. Similarly, for the problem B, square root of 4 over 9, you will get square root of 2 over 9. You can actually rewrite 2 over 9 times 2 over 9. And since it have like 2 copies, right? 2 copies. Then you can just eliminate 1 copy because of the square root and get the answer as, oh, sorry, not 2 over 9, 2 over 3. 2 over 3. And that's be the answer. Okay. Now, here is special case. I would like to have like a star for this one. Do you know about C? C is a variable, right? Since C is variable, I'm going to have 2K if C greater than 0. Okay? If C is greater than 0, what happened? So say for example, C is C is 1. I even include a 0, like 1, 2, and something. Right. Okay. So what you're gonna have is square root of c squared will be equal to c, because you can cancel 2, right? You can cancel the 2, the power 2 become just c. So, or you can think about like, oh, what about you have like square root of 2 square, right? And that's going to be example here. That will be just 2, right? Okay. Now, That is one case. What about if c less than 0? What happened? So say c equal to, I know, maybe c equal to negative 3, right? So example. So we have square root of a negative 3 square. What is that going to be? Okay. Don't want to tell me it is negative 3. Okay. If you say negative 3, that is wrong. Okay. Remember that. Remember that. You need to square first, right? You need to do the square first, the power 2 here first. So then you're going to have a square root of number 9. And square root of number 9 going to be give you 3. So what happened? From a square root of negative 3 square, you get only 3. So look like from c, from a square root of c square, instead of having c, now I have the negative of c, like in another, like the different sign. Look at that, different sign between the first c and the output. Let me let me move to the next one. Okay. So I will circle this as the answer and also this one as the answer. For c greater than or equal to 0, for c less than 0. Okay. All right, so now let we have we're gonna use a calculator to evaluate 25 and see what it's gonna give you. So you wanna use calculator, just TI-83 over here and put a square root of 25, and then the calculator is going to give you the answer as just 5. You're not going to have negative 5. So that's the reason why I always try to state that you cannot say square root of 36 going to be equal to negative 6, right? Let's try a square root of 36 to make sure meter 2 telling you the truth. So look, it's going to give you 6. It will not give you negative 6. That is the reason why I keep saying that a square root will never give you a negative number. Okay. So what else I need to tell you? So let's talk about the cube root. Cube root. Okay. So cube root is when n equal to 3. The index n equal to 3. So you have like if b to power n, power 3 equal to a, then if you want to rewrite in the form of the radical, you have cube root like this, right? Of a, okay, cube root of a, cube root of cube root of a, yes, a equal to b. Yes. Okay. So this is called cube root. And what else do I need to let's finding a cube root. Okay, so example 2. Let's say I also want to evaluate. I have a cube root of number 8. Okay. You know that. Number 8 here, I can rewrite it as 2 times 2 times 2, right? Everyone know that. Number 8 can be rewrite as 3 number 2. And that can be rewrite as 2 to the power third, right? So since it's become 2 to the power third, now I can just use the cube root, cancel for the power 3, right? And then I have only 2 as answer. Okay. Let's move to part B. What if I have a cube root of 20, let's say negative 27? Okay, what happened now? Are they going to give you a negative number or are they going to give you a positive number? Remember that this is a cube root, not a square root. So let's see what it looks like. Okay, let me factor the negative 27. What is going to be? Okay, I know that negative 27 can be rewritten as negative, say negative 3 times another negative 3 and time with another negative 3. So you can see that. And so I can rewrite this as a negative 3 to the power 3. Okay. So in this case, is can cancel the cube root with the power 3, become negative 3. And it's still giving you a negative number. So note that okay, cube root or root with the odd index will give you let's say will can give you can give you positive or negative value. Okay, so it could be positive or negative. It doesn't have to be just positive. So it doesn't matter. It doesn't have to be only positive. It could be negative. Okay, for the cube root. Okay, so now let's have another example. Say C. I have a cube root of D to the power 6. What is that going to be? I can rewrite this as I can factor this d to the power 6 as d to the power 2 times d to the power 2 and times d to the power 2. See that? You have 3 copy of d squared. And I can rewrite it as d to the power 2, everything to the power 3, cube root of that. And then I can just have d to the power 2. Since the cube root can cancel the power 3, right? That should be the answer. And remember, that's for the odd index. I don't have to worry about the positive and negative value later. So, another note. Another note that I want you to write is, say, if n is odd, right? If the index is odd, then the cube root of n, the root n of a is a negative, or just is negative, right? So, for example, cube root of -8 will be equal to -2. In another side, if n is even, then root n of a is root n of a. I should also okay. I should also state like this. Note for a less than 0. For a less than 0. If n is odd, then n root of a is negative. Or I even can just write like this. 0. If n is even, then the root n of a is not a real number. What does that mean, not a real number, right? What does that mean is not a real number? Unless, so that's called is a complex number. And I will talk about complex number later, okay? Okay, so for example, square root of 94, or maybe let's have 4 root of -8. This is not a real number. Okay, it's not a real number. So 4 let me write over here. For a is greater than 0 or even greater than or equal to 0. Okay. Then root n of a is a positive number. Always. Okay. Even either n is even or odd. So it doesn't matter for this case. Okay. Okay, so let's have another example. Let's see. Uh-oh. So example what example we are here? 3. Example number 3. Let's say find nth root. Find nth root. So, I want to find the root 4 of 16. How can I find this root? Remember that if you have the index of the root is 4, you need to factor the radical to become 4 copies of a number. Okay, so let's factor it. I have 4 of 2 times 2 times 2 times 2. And this can be rewritten as 4 root of 2 to the power 4. And then I can right away say, oh, this is a number 2. Okay. Now, let's have B at say fifth root of negative 32. Yep. Only the even is an okay. So let's take a look at the notes over here. In this case, I have radical is a negative number, right? Negative number. Let's see here. And also, and the index n is an odd number, right? See that? Now 5. So then this root has to be less than 0. Okay. So I will rewrite and factor this negative 32 become say root of 5 of negative 2, negative 2, negative 2, negative 2. And that will rewrite as root 5 of negative 2 to power 5. And that just give you negative 2. That is net less than 0 as the note that we have right above. Okay. Okay, so now let's talk about C. I have say 4 root of a negative 80, let's say 81. Or even it's just gonna have like square root of negative 81. I know that this giving you an n equal to 2, which is even, right? And you have a in here is less than 0, which is negative 81, less than 0. So you can take a look over here, the second case. No, the first case with n is even, then the root n of a is not a real number. It's a complex number. So this will give you a complex number. And again, I will talk about this later, not now. Okay. Let's move to the D. I have negative of square root of 81. This is totally different with the square root of negative 81. Okay, you guys should remember that. And I can rewrite it as negative of square root of 9 times 9, which equal to negative of square root of 9 squared. You're gonna have a negative of 9. Okay. So remember that the negative outside will stay, but square root of 9 squared gonna be equal to 9. Just don't mess up with that, okay? Okay, so now this will be the answer. Okay. So what else do I need to talk? I'm gonna talk about absolute value. So from now on, you can remember that in general, the expression that x square root of x squared will equal to the absolute value of x. Okay. Remember from the previous section, right? I have talked about absolute value of if I have an equation of absolute value of x, right? Let's say example. If I have absolute value of x equal to say 3, then I'm gonna have 2k for solution is as x equal to 3 or x equal to negative 3, right? So for the case that let's say square root of x squared equal to I don't know, maybe equal to 2. I can rewrite the left hand side as absolute value of x equal to 2. And that means you can have x equal to 2 or x equal to negative 2. So that is a reason why when you see like when you see equations such as the x squared equal to 4. What can you do for this case is you have to do square root both hand side, right? In order to find x, you need to square root both hand side. Okay. And the left hand side now become absolute value of x. The right hand side now become square root of 4 equal to 2. And then finally, you can just have x equal to 2 or x equal to -2. And if you want to check, you can substitute x equal to 2 into the original function. I mean original equation. So x squared equal to 4. And then you have 2 squared equal to 4. That is true statement. Then this is one solution. Okay. What about x equal to -2 into x squared equal to 4? You also have -2 squared equal to 4. And that is true statement also. So that means this is a solution. Okay. So, okay, so let's have another example, D. And I say, what about square root of x plus 1 square equal to, I don't know, let's say 4. And I have x plus 1 absolute value equal to 4. And that will give you x plus 1 equals to 4 or x plus 1 equals to -4. So then I have x equal to 3 or x equal to -5. You subtract both and side by 1. Okay. That should be the answer of this one. Okay, so let's let me see. Let's talk about domain of a square root function. Okay. So let's say f of x equal to square root of I know, let me just or I'm gonna just say like a radical or square root of a box has a requirement S. The box had to be greater than or equal to 0. So I need to so f of x equal to a function a radical or square root of something who has domain with the box greater than or equal to 0. Let's have an example. What example do I have right now? 3, right? Let's say 4. Find domain of A. Fx equal to square root of x minus 1. So you will have domain will be, what's the radical in here? What is the box in here? This guy, right? X minus 1 greater than or equal to 0. And if you solve for x, you will have x You add both hand side by 1. You have x greater than or equal to 1 at the domain. Okay. For B, f of x equal to let me see, square root of 4 minus 2x. So then I'm gonna have domain is 4 minus 2x greater than or equal to 0. And then if you subtract both sides by 4, you're gonna have negative 2x greater than or equal to negative 4. And and now you need to divide both hand side by negative 2, right? So what you do is you have left hand side gonna be x, the right hand side gonna be 2, but the inequality now change direction as less than or equal to 2. Okay, so x has to be less than or equal to 2. Okay, and this is the domain. What else? Let's say C f x equal to square root of x squared plus 1. And what you need is you need x squared plus 1 greater than or equal to 0. But because x squared is always greater than 0 already, so x squared plus 1 even can be greater than or equal to 1. And that means I can just say x squared plus 1 greater than or equal to 0 is always true. So true for all x value. So that means the domain in here is all real number. Or I can just say like from negative infinity to positive infinity. Okay, so that is for the domain of a square root function. Okay, so that is for the domain of the square root function. What about the domain of a cube root function? So for this one, you have to remember that you can put any value. Let's say function f x equals to cube root. I know cube root of g of x. Yeah, right. And you can have like for every value of x, this function will always define. So domain is just for the cube root. For the cube root function, is always will give you from negative infinity to positive infinity. Okay, so if you see a cube root function and as asking for the graph, you can just say I mean sorry, for the domain, you can just say all number or from negative infinity to positive infinity. Okay, so lastly, let's talk about the graph of let's say square root function and cube root function. Okay. So let's compare over here at fx equal to square root of x, and here is g of x equal to cube root of x. Okay, so I can start with table value of x and g of x, right? Let's start with let's say 0 for x. You're gonna have okay, you cannot have x is negative, right? So you're gonna start at x is equal 0 in here, right? Because it is square root, so you start with x equals 0. Or I can say domain is x greater than 0, right? You know that. So I start with 0, and I have f of x is square root of 0, which is 0. And 1, it's going to be square root of 1, it's just 1. And then I'm going to start with, I'm going to have 4, square root of 4 going to be equal to 2. What else? Say 9 and 3, right? And so on. I'm just going to have up to 3 is enough. In the cube root function, I know that domain is Oreo. So I can, can have x and g of x. I can start from the negative number. Let me start with a negative of I don't know, maybe negative of let me see, negative 1. Let's say that. Let's see, I can have negative 8. Let's say I have negative 8. I have 0x will be cube root of negative 8. If you want to try the calculator, let me show you. So do I have negative? Oh, I don't have that one, but there's another way you can write it as power form. So that's gonna be negative 8 to power 1 divided by 3. That should be a negative number. Oh, let me see. Something goes wrong. Okay. I see the mistake. I should write as negative 8. Okay, so let me rewrite over here. I also should have a note. Note that. Let's say a, so square root of a will be, if you rewrite it in the form of the power, you have a to power 1/2. Cube root of a, you can rewrite it as a to power 1/3. So the index will be the denominator of the fraction power. Then let's say let's have like 4 root of a. I can rewrite as 8 over 1 4. So that is the reason why for g of x here is going to have negative 8 to power 1/3, right? Um, if you have like cube root of negative 8, you can rewrite it as negative 8 to power 1/3. Why I write this? Because in the calculator, if you don't have the cube root, you can just use the power and to power 1/3. You should not write 1 divided by 3 over here like the above. It's going to be the whole number. You should have a power of 1 divided by 3 because at that case the calculator will understand you write as you have the power as 1 over 3. If I don't have the parentheses as above, it means that negative 8 to power 1 and everything divided by 3. Okay, so let's see. Okay, so I have negative 2 as the answer. So I'm going to change this at negative 2. Okay, so what else? I have negative 1, go with negative 1, 0 will be 0. And then say 1, cube root of 1 gonna be 1. And 8 gonna be 2. Okay. So let's grab it. Okay, so I have here, I have 0, 0, 1, 1, 2, 1. Let me see. Maybe I need to have different scale. So let's say here, 1, 1, 2, 4. Wait, 4, 2. Sorry, 4, 2. Okay, so 1, 2, 3, 4. Here's 4, 4, and 2. Okay, over here, and 9, 5, 6, 7, 8, 9. Here's 9, 9, and 3. Here's 9, and 3. Okay, so to graph, we'll go like this. Okay, go like that, and it keep going up, but not really like it's going up, but not quick up. Okay, that for the f of x. What about is y is x? What about over here? We have middle one better. Okay, so I have negative 8. So 1, 2, 3, negative 1. 2, 3, 4, 5, 7, 8, negative 8 over here. And then 1, 2, negative 2 over here. So that will give you negative 2. And then what else? Negative 1 and negative 1 over here. This one. What else? 0, 0. Okay, go to this point. And 1, 1. And then 8, 2. So here's 4, here's 8. And then here 2. So have the line go like this. Okay. So this is G-Wax, and you can see the difference between the cube root and the square root function graph. Okay, so I have finished section 10.1, and we'll see you in the next section. Okay.